Welcome! Tonight, I invite you to set aside the worries of the day and join me on a journey through deep time. Close your eyes, if you like, and imagine the world not as a frantic, busy place, but as a vast, ancient entity moving with a slow and steady rhythm. We often think of the ground beneath us as a solid, unmoving foundation, the very definition of permanent. But in the grand scale of the universe, the Earth is far from a static, frozen rock. It is a dynamic, living system composed of many distinct layers, each with its own character, density, and temperature. The outermost shell of our planet, the part we walk upon, where the mountains rise and the oceans rest, isn't a single continuous piece. Instead, it is broken into several massive, jagged sections known as tectonic plates. These plates are like the pieces of a great planetary puzzle resting on something much deeper and much warmer. They are in constant, silent motion, drifting at a pace so slow that we cannot feel it in our daily lives. They move only a few centimeters each year, roughly the same speed at which your fingernails grow. It is a pace that honors the patience of the universe. Before we travel deeper into the heart of our world, if you find these quiet explorations of science soothing, I invite you to gently subscribe to the channel or leave a like on this video. It helps ensure this space remains a peaceful sanctuary for your rest. And I'm so glad you are here with me. Now, let us settle in. Take a slow, deep breath and feel the weight of your blankets as they settle over you. Feel the support of your pillow and the stillness of the room around you. As you relax, we are going to leave the surface behind. We are going to move past the cool evening air, past the soil, and past the deep roots of the oldest trees. We are sinking down through the solid bedrock, moving toward the internal heat that drives the entire world. This heat has been radiating from the center of the Earth for billions of years, a remnant of the planet's violent birth and the steady decay of elements deep within. As we descend, the world above fades away, replaced by the steady, warm pulse of the inner Earth. We are moving toward the layers that hide beneath the surface, where the rock begins to change, and the story of our wandering continents truly begins. As we move deeper into our imagination, picture the Earth as if it were a massive, ancient onion, made of layer upon layer of different materials, each one heavier and denser than the one above it. This layering happened billions of years ago, when the Earth was still molten and young, allowing the heaviest metals to sink to the center while the lighter rocks floated to the top. Before we explore these depths further, take another slow, gentle breath. Feel the soft weight of your blankets against your skin, a comforting boundary between you and the room around you. There is no rush here. The Earth has taken eons to form, and we have all the time we need to understand its quiet secrets. The very top layer, the one we call home, is the crust. Compared to the rest of the planet, the crust is incredibly thin, much like the delicate papery skin of that onion. In some places, beneath the vast floors of the oceans, it is only about 5 kilometers thick. Even under the highest mountains, it rarely reaches more than 70 kilometers. It is brittle, cool, and solid, a fragile shell protecting us from the immense heat that dwells far below. just beneath this thin shell lies the mantle. This is the Earth's largest layer, making up about 84% of the planet's total volume. It is nearly 3,000 kilometers thick. The mantle isn't quite liquid, but it isn't quite solid either. Scientists often describe it as being semi-solid or plastic. Imagine a material like thick, warm taffy or heavy, slow-moving honey. It can flow, but it moves with a patient slowness, shifting only over millions of years. Deep at the very center of this sphere lies the core, divided into two distinct parts. There is the outer core, a sea of liquid iron and nickel that flows like water, and the inner core, a solid ball of iron about the size of the moon. The temperatures here are staggering, reaching up to 6,000 degrees Celsius. This is as hot as the glowing surface of the sun. It is a sun within our own world, a source of incredible energy trapped beneath thousands of miles of rock. This intense heat from the core is the engine that drives everything on the surface. It creates what we call convection currents. Just as warm air rises in a room, the heat from the core warms the base of the mantle. This warmed rock becomes slightly less dense and begins to rise very slowly toward the surface. As it nears the cool crust, it begins to spread out and cool down, eventually becoming heavy enough to sink back toward the center once more. This slow rhythmic churning, a great hidden circle of heat and stone, is what moves the world above. It creates a subtle, persistent pressure on the underside of the crust as we rise back up from the glowing heat of the core. Moving through the slow-moving mantle, we return to that thin, brittle outer shell. We are moving toward the physical pieces of the crust that sit atop this churning engine, ready to see how they are shaped and moved by the power deep within. As we emerge from the deep churning heat of the mantle, we find ourselves back at the surface, standing on what scientists call the lithosphere. The name comes from the Greek word lithos, meaning stone. It is a fitting name, for this is the rigid, cool, and protective outer shell of our world. But this shell is not a single, solid piece of stone like the shell of an egg. Instead, it is more like a giant, spherical jigsaw puzzle, wrapping around the globe in a series of massive, interlocking sections. Take a moment to imagine those pieces. In your mind's eye, see the edges of the continents. If you look closely at a map of the world, you might notice how the eastern coast of South America seems to reach out toward the western coast of Africa, as if they were once held together and then gently pulled apart. This is because they are part of these great puzzle pieces, which we call tectonic plates. There are about 15 to 20 of these major plates, along with many smaller ones, all nestled against each other. Some are vast, like the Pacific Plate, which sits beneath the world's largest ocean. Others carry entire continents on their backs, moving with a quiet, unstoppable dignity. These plates include the North American Plate, the Eurasian Plate, and the Antarctic Plate, which holds the icy southern pole in its steady grip. It is a strange and wonderful thought to realize that the ground beneath your bed, the very floor you are resting on, is not as fixed as it seems. These plates are not anchored to the center of the earth. Instead, they float. They rest upon a slightly softer, warmer layer of the mantle known as the asthenosphere. You can imagine the plates as giant rafts of stone drifting on a sea of slow-moving, semi-liquid rock. Because they are floating, they are never truly still. They are constantly, silently drifting, moving at a pace so slow that it is almost impossible for our human senses to detect. In the time it takes for you to take one deep, relaxing breath, a continent might move only a microscopic distance. Over the course of a year, they may only travel a few centimeters, about the same speed that your fingernails grow. This silent movement is happening right now, in the stillness of the night. While the world sleeps, the great plates are shifting, nudging into one another or pulling away to create new space. There is a profound peace in this realization that the earth is a living, changing entity, performing its slow work with a patience that spans millions of years. We often think of the ground as the very definition of stability, but in the grand scale of time, it is a fluid and shifting mosaic. This drifting doesn't happen by chance. It is made possible by the unique nature of the layer just beneath the plates. This layer, the asthenosphere, acts as a sort of cosmic lubricant, a gentle cushion that allows the heavy lithosphere to glide across the planet's interior. To understand how such massive weights of stone can move at all, we must look closer at this hidden, honey-like world beneath our feet. Imagine a layer of the earth that is neither quite solid nor quite liquid, a hidden realm where the rules of stone begin to soften. This is the asthenosphere, a name derived from the Greek word for weak, though it is anything but fragile. It is a vast subterranean ocean of rock, but it does not splash or wave. Instead, it flows with the consistency of thick, warm honey or heavy molasses, moving with a patience that defies human time. As you lie there, perfectly still, try to visualize this deep, warm layer. It begins roughly 100 kilometers beneath the soles of your feet and extends down to a depth of about 700 kilometers. In this space, the intense heat from the Earth's core meets the crushing weight of the layers above. It is a place of perfect balance, where the rock is hot enough to stay flexible, yet under enough pressure to remain technically solid. Scientists call this state ductile. It means the rock can be stretched and molded without ever snapping, like a piece of warm taffy or a thick, viscous wax. Within this deep, dark layer, there are slow, rhythmic currents. Imagine the way warm air rises in a sunlit room, or the way heat circles in a pot of thick soup. Deep inside the earth, the hottest rock from the mantle rises slowly toward the surface, cools slightly, and then sinks back down in a never-ending circular dance. These are convection currents, the engine of our planet. They move with a majestic, heavy grace, churning so slowly that a single cycle can take millions of years to complete. Take a slow, deep breath and feel the weight of your blankets pressing down on you. Just as you are supported by your bed, the great tectonic plates of the world are supported by this slow-moving flow. The asthenosphere provides the gentle, yielding surface that allows the plates above to glide. It is a silent, liquid-like movement of solid rock, occurring in total darkness, miles beneath the bustling life of the surface. This movement is what allows the continents to drift across the face of the globe. Because the asthenosphere is so viscous and thick, it limits the speed of the plates to just a few centimeters every year. It is a pace of incredible restraint. If the Earth moved any faster, our world would be a place of constant, violent upheaval. But because of the thick, honey-like nature of the asthenosphere, the changes are gradual, measured, and quiet. This internal flow is the secret heartbeat of the Earth. It is the reason why mountains rise and oceans widen. Every mountain peak you have ever seen and every deep valley you have ever walked through owes its existence to this slow, churning layer of plastic rock. It is a beautiful, hidden mechanism that has been functioning for billions of years, long before the first forests grew and long before we were here to wonder at it. For a long time, the idea that the ground could move at all was considered impossible. The world seemed too solid, too permanent to ever change its shape. It took a person with a unique sense of observation and a deep, quiet curiosity to look at the map of our world and see something that everyone else had missed. They began to realize that the continents were not just random shapes, but pieces of a story that had been unfolding since the very beginning of time. This realization would eventually lead us to understand the true ancient history of the ground we walk upon. In the early years of the 20th century, a German scientist named Alfred Wegener spent many quiet hours looking at maps of the world. He was a man of deep curiosity and patient observation, a meteorologist who looked at the Earth not as a collection of fixed, unmoving countries, but as a living system in constant, subtle flux. As he traced the outlines of the continents with his eyes, he noticed something that many had seen before but few had dared to take seriously. He saw a shape, a pattern, a lingering memory of a different world. If you were to close your eyes now and visualize a map of the globe, focus your mind on the vast Atlantic Ocean. On one side, you have the prominent, bulging curve of Western Africa. On the other, the deep inward indentation of the eastern coast of South America. Wegener noticed that these two coastlines looked almost exactly like two pieces of a jigsaw puzzle that had been pulled apart by a gentle hand. The fit was too perfect to be a mere coincidence. The curve of Brazil seemed to nestle perfectly into the hollow of the African coast, like two people sleeping back to back, once joined in a single peaceful embrace. In 1912, Wegener stepped forward with a bold and beautiful idea that he called continental drift. He proposed that the continents were not anchored forever in their current positions, but were instead like great granite ships slowly sailing through the darker, denser rock of the ocean floor. He imagined a time, hundreds of millions of years in the past, when all the land we know today was gathered together in one place. He saw a world where there were no vast oceans separating the continents, but rather one enormous, unified landmass surrounded by a single infinite sea. At the time, the scientific community found this idea difficult to accept. The Earth seemed far too solid, and the forces required to move an entire continent seemed unimaginably vast. But Wegener remained undeterred. He spent the rest of his life looking for the quiet clues the Earth had left behind, the fingerprints of a shared history. He began to look beyond the shapes of the coastlines and into the very fabric of the land itself. The idea of a single ancestral home for all the world's land is a peaceful one. It suggests that despite the thousands of miles of deep blue water that now lie between us, the ground beneath our feet was once part of the same neighborhood. This realization changed everything. It meant that the history of one continent was inextricably linked to the history of another. To prove his theory, Wegener knew he had to look closer at the Earth, searching for the tiny ancient treasures hidden within the layers of rock and soil, the silent witnesses that could tell the story of how the world once was. He began to find these clues in the most unexpected places, in the forms of ancient life that had been frozen in time for millions of years. Imagine, for a moment, that the Earth is a vast ancient library, and every layer of rock is a page in a book that has been resting on the shelf for millions of years. Alfred Wegener began to read these pages, looking for the tiny, delicate clues that the wind and the waves could not wash away. He found them in the form of fossils, the silent, petrified remains of life that existed long before the first human ever walked the earth. These fossils were like letters from the past, sent from one continent to another, proving that they were once the closest of neighbors. If you were to walk through the quiet, frozen valleys of Antarctica today, it would be hard to imagine it as anything other than a world of white and blue ice. But deep within the cold stone of that continent, scientists have found the fossilized leaves of an ancient plant called Glossopteris. It was a woody, seed-bearing shrub with heavy, tongue-shaped leaves that once carpeted the ground in vast green forests. What makes this discovery so remarkable is that these same Glossopteris fossils are found in the sun-drenched soils of India, the wilds of Australia, and the plains of South America and Africa. These seeds were too heavy to be carried by the wind across thousands of miles of open ocean. They could not float across the salty seas and survive. The only way for the same plant to have grown in all these distant places was if the land itself was once connected, allowing the forests to spread slowly and naturally across a single, continuous landscape. As you breathe in slowly, imagine those ancient emerald green leaves rustling in a breeze that blew across a world without borders, a world where the cold peaks of Antarctica and the warm valleys of India were part of the same backyard. Wegener also looked to the animals of the deep past. He studied a small, gentle reptile called the Mesosaurus. This creature lived about 270 million years ago. It was a freshwater animal, shaped a bit like a small crocodile, with a long snout and paddle-like limbs. It spent its days drifting through quiet lakes and rivers. Its fossils have been found in only two places on Earth, the eastern coast of South America and the southwestern coast of Africa. The Mesosaurus was a creature of fresh water. It was physically incapable of swimming across the thousands of miles of the salt-heavy Atlantic Ocean. It would be like a garden lizard trying to cross the widest sea, and yet there it is, preserved in the stone on both sides of the water. To Wegener, the conclusion was as clear as the stars on a cloudless night. These animals didn't cross the ocean. They lived and died on a single piece of land that later, very slowly, tore in two. It wasn't just the life that matched. It was the very bones of the earth itself. Wegener found that the ancient mountain ranges of South Africa lined up perfectly with the mountains of South America when the two continents were placed side by side. The coal fields of Europe matched those of North America, It was as if a giant had torn a photograph in half, and Wegener was the first person to notice that the jagged edges still fit together, line for line, color for color. These clues tell a story of a time when life walked freely across lands that are now separated by vast dark abysses of water. It is a comforting thought in the stillness of the night to realize that the world has a memory of being whole. All of these fragments of evidence, the ferns, the small reptiles, the matching mountains, pointed toward a single magnificent reality. They were all part of one immense ancestral home, a giant landmass that held all the world's beauty in one place. This great union of continents, this ancient cradle of life, is what we now call Pangaea. Pangaea. The name itself feels heavy and ancient, like a deep bell ringing through the halls of history. It is derived from the ancient Greek words Pan, meaning all, and Gaia, meaning Mother Earth. It was a time, roughly 300 million years ago, when the world was truly whole. Close your eyes for a moment and try to imagine a map of the world where there are no vast gaps of blue between the continents. Instead of the familiar scattered shapes we see today, imagine every piece of land nestled together, shoulder to shoulder, in a giant, C-shaped embrace. In this unified world, there was a profound sense of geological peace. You could have walked from the red deserts of what is now North America, across the lush equatorial forests of Africa, and all the way down to the icy reaches of Antarctica, without ever stepping foot in the ocean. It was a world without borders, where the life we discussed, the ferns and the small reptiles, thrived in one continuous garden. The climate was different then, because the landmass was so enormous. The deep interior was a place of vast, quiet deserts, far from the cooling influence of the sea. While all the land lived together on one side of the globe, the rest of the planet was covered by a single, immense body of water. This was Panthalassa, the all-ocean. Imagine the sheer scale of it, a blue world so wide that the sun would rise and set over nothing but waves for thousands upon thousands of miles. It was a time of deep planetary symmetry. The land was one, and the sea was one. The tides pulsed against a single, continuous coastline, a rhythmic heartbeat that governed the edges of the world for millions of years. But the Earth, in its quiet power, is never truly still. About 200 million years ago, the heat trapped beneath this massive crustal blanket began to build. The union began to soften. It wasn't a violent snap, but a slow, rhythmic pulling apart. Imagine the sound of a heavy silk cloth being pulled so slowly that you can barely hear the fibers stretching. Great rifts began to open in the earth, and the waters of Panthalassa began to trickle into these new narrow gaps. This was the birth of the Atlantic and Indian Oceans, small, shallow seas at first, cradled by the breaking land. As you listen to the story of this ancient transition, take a slow, deep breath. Feel the weight of your blankets and the stillness of the air around you. The earth performs its greatest works in silence and over spans of time that we can hardly imagine. The tearing of Pangaea took millions of years, a timeline so vast that a human life is but a single heartbeat in the process. Visualize the continents drifting away from one another at the same speed your fingernails grow. It is a movement so gentle, so patient that it feels more like a dream than a physical force. It is important to remember that while Pangea is the most famous of these great unions, it was not the only one. It was simply one chapter in a much older book. The Earth has a long, long memory of coming together and drifting apart. Pangea was just one in a series of supercontinents that have assembled and disassembled over billions of years. A grand, slow-motion pulse that has shaped the very foundation of life. Before there was Pangea, there were others, each with its own story, its own mountains, and its own quiet oceans. This rhythmic coming together and drifting apart is what geologists call the supercontinent cycle. It is helpful to think of this process, the slow, heavy migration of the world's land, as the grand, steady heartbeat of our planet. It is a pulse that beats only once every few 100 million years, a slow, deep thrumming that has been echoing through the silence of space since the Earth was very young. As you settle deeper into your pillow, imagine this cycle as a long, slow breath. The Earth breathes in and the continents gather. It breathes out, and they scatter across the vast blue expanse of the oceans. Before the familiar shapes of Pangea ever formed, there was a world we call Rodinia. It existed about 1 billion years ago. At that time, the land was a barren, silent expanse. There were no forests yet, no animals walking the shores, just the raw, rugged beauty of stone and tin under a younger sun. Rodinia stood as a single mass for hundreds of millions of years before it, too, felt the warmth from below and began its long, splintering journey. It stayed together for nearly 250 million years, a span of time so long it makes the entire history of human civilization look like a single grain of sand on an endless beach. If we look back even further through the soft mists of deep time, we find Columbia. This supercontinent, sometimes called Nuna, existed roughly 1.8 billion years ago. And even before Columbia, there was Kinnerland, assembled nearly 2.7 billion years ago, when the Earth was still in its turbulent youth. Each time the continents gathered, they stayed for a while, resting in a unified embrace, before the internal heat of the planet nudged them apart once more. There is a profound sense of peace in this continuity. The Earth has a physical memory of every assembly and every disassembly. It carries the scars and the seams of these ancient unions in its very bones. The grains of sand on a beach today might have once been part of a mountain range in the center of Kinnerland. Billions of years ago, the world is a closed system of constant recycling, where nothing is ever truly lost, only rearranged into new and beautiful patterns. The granite in our buildings and the stones in our gardens are the recycled remains of worlds that existed long before the first flower ever bloomed. This cycle tells us that the Earth is not a finished product, but a work in progress. It is a living, changing entity that is never truly still. Even as you rest, the ground is performing its slow-motion dance. But as the continents drift, they must make room for one another, and they must have a source of new material to keep the dance going. To understand how the Earth creates the space for this movement, we must turn our gaze away from the dry land and look toward the deepest parts of the sea. We must descend into the cool, dark waters where the crust is being born even now in the quietest, most hidden corners of the world. Imagine your mind drifting away from the sunlit coastlines, sinking slowly beneath the surface of the Atlantic Ocean. As you descend, the bright turquoise of the shallows fades into a deep, quiet indigo. The sound of the crashing waves disappears, replaced by a profound, heavy silence. The pressure of the water above is like a soft, cool blanket, pressing gently and evenly from all sides. Here, in the eternal twilight of the abyss, lies a secret that remained hidden from human eyes for most of our history. Stretching from the subarctic waters near Iceland all the way down toward the Southern Ocean, there is a mountain range unlike any found on a land. It is called the Mid-Atlantic Ridge. It is the longest mountain chain on our entire planet, spanning a staggering 16,000 kilometers. If you were to walk its length, you would traverse nearly half the circumference of the Earth. Yet, it sits silently at the bottom of the sea, its peaks and valleys shrouded in total darkness and immense pressure. Take a slow, rhythmic breath and imagine the scale of this hidden world. These mountains are not covered in forests or snow, but in layers of fine, pale sediment and dark volcanic rock. In most places, the peaks of this ridge sit 2,000 to 3,000 meters below the surface of the water. It is a landscape of jagged cliffs and deep, narrow rift valleys that follow the gentle curve of the continents on either side. It is as if the Earth has a giant, submerged spine, mirroring the shapes of the land masses that were once joined together. Scientists call this a divergent boundary. It is a place where the Earth's crust is being gently, persistently tugged in opposite directions. It is a slow movement, a rhythmic pulling, as if the planet is stretching after a long, deep sleep. This ridge is the visible evidence of that stretching. While we often think of mountains as being formed by things crashing together, these underwater mountains are formed by the Earth pulling apart. There is a strange, lonely beauty to these peaks that no human eye usually sees. Occasionally, the ridge rises high enough to break through the surface of the ocean, creating islands like the Azores or the volcanic landscapes of Iceland. But for the most part, the Mid-Atlantic Ridge exists in a world of absolute stillness. There is no wind there, no storms, only the slow, cold currents of the deep sea and the internal heat of the planet rising from below. Feel the stillness of your own room, mirroring the quiet of this underwater world. The ground beneath us may feel solid and unchanging, but here at the center of the ocean, the Earth is constantly, quietly making more of itself. This ridge is not just a static monument of stone. It is a place of birth. It is the starting point for a process that keeps our planet's surface in constant motion, a process where the very floor of the ocean begins a journey that will last for millions of years. This slow, steady creation is what we call seafloor spreading, and it is the heartbeat of the moving Earth. Imagine, if you will, the floor of the ocean acting like a massive, slow-motion conveyor belt. In the deep silence of the abyss, far beneath the waves and the light of the sun, the Earth is engaged in a continuous act of creation. This is not a sudden or violent event, but a steady, rhythmic pulse that has been beating for millions of years. Take a slow, deep breath. Feel the stillness of the air around you and let your mind drift down to those dark, quiet depths. Here, at the center of the mid-Atlantic ridge, the Earth's crust is thin and fragile. As the great tectonic plates on either side are pulled apart by the slow currents of the mantle, a rift opens up, a long, narrow wound in the sea floor. From deep within the earth, molten rock, or magma, feels the release of pressure. It rises upward, drawn toward the cold, dark water above. As this glowing magma reaches the seabed, it meets the frigid temperatures of the deep ocean. The transition is immediate and quiet. The liquid fire cools and hardens, solidifying into a heavy, dark volcanic rock known as basalt. This fresh basalt is the newest material on the surface of our planet. It fills the gap left by the moving plates, stitching the Earth back together even as it is pulled apart. But the process does not stop there. As more magma rises from below, it pushes the older, already cooled basalt away from the center of the ridge. The seafloor is literally being pushed aside to make room for the new. It is a beautiful, patient cycle. The rock that was formed yesterday pushes the rock formed 1,000 years ago, which in turn pushes the rock formed 1,000,000 years ago. In this way, the entire ocean floor is constantly being renewed, moving slowly away from the central ridge toward the distant edges of the continents. The scale of this movement is small, yet its impact is world-shaping. Because of this quiet, persistent spreading, the Atlantic Ocean is actually growing wider every single day. If you were to measure the distance between the coast of North America and the coast of Europe, you would find that they move further apart by about 2.5 centimeters every year. To put that into perspective, it is roughly the same speed at which your fingernails grow. It is a gentle thought that as you sleep and as the years pass, the very geography of our world is shifting by the width of a finger. Over the course of a human life, the ocean grows by about the height of a person. Over millions of years, this fingernail's pace has created entire oceans and moved continents across the globe. We know this is happening not just because we can measure the distances with satellites, but because the Earth has left us a trail of clues. Deep within the cooling basalt, there is a hidden history, a magnetic record of the planet's past. Just as the rings of an ancient tree tell the story of the seasons, the rocks of the seafloor act as a giant tape recorder, capturing an invisible force that has guided the Earth for eons. Imagine for a moment that the Earth is not just a planet of rock and water, but a giant magnet. Deep within the core, the churning of liquid iron generates an invisible force field that stretches far out into space, protecting us from the solar wind. This magnetic field is what makes a compass needle point north. But if you were to travel back in time, hundreds of thousands of years, you might find that your compass behaved very differently. You see, the Earth's magnetic poles are not fixed. Every few 100,000 years, for reasons scientists are still working to fully understand, the magnetic field weakens, wobbles, and then completely flips. North becomes south, and south becomes north. It is a slow, silent transition that has happened hundreds of times throughout our planet's long history. It is a gentle reminder that even the most fundamental forces of our world are subject to the slow rhythmic cycles of change. While these reversals might seem like a chaotic mystery, the seafloor has kept a perfect orderly record of every single one. When the molten basalt rises at the mid-Atlantic ridge, it contains tiny grains of a mineral called magnetite. While the rock is still liquid and hot, these microscopic crystals are free to move. Like tiny natural compass needles, they align themselves with the Earth's magnetic field at that exact moment, pointing toward whatever pole is currently north. As the lava meets the cold ocean water and solidifies, these tiny needles are frozen in place. They become a permanent record of the planet's magnetic state at the moment the rock was born. Because the seafloor is constantly spreading outward from the ridge, it creates a series of magnetic stripes. On either side of the ridge, you find matching bands of rock. One band might show a normal magnetic orientation, while the next band, formed thousands of years later after a polar flip, shows a reversed orientation. It is as if the seafloor is a giant, slow-moving conveyor belt of magnetic tape. By reading these stripes, scientists were able to solve the mystery of how the continents move. They saw perfect symmetry, a mirror image on both sides of the mountain range, telling the same story of birth and movement. The seafloor acts as a giant tape recorder, capturing the invisible heartbeat of the Earth's core and preserving it for millions of years in the deep, quiet dark. Take a slow, deep breath and imagine these invisible patterns stretching out for thousands of miles beneath the dark waves. There is a profound sense of order in this process. The Earth does not just move, it remembers. It carries the signature of the ancient magnetic field within its very foundations, a silent map of time etched into the stone. But, as we have seen, the Earth is a balanced system. If new crust is being born and the oceans are widening at the ridges, the planet cannot simply grow larger and larger like a balloon. The Earth must maintain its shape. For every inch of new land created in the middle of the sea somewhere else, the old crust must be reclaimed. We are moving now away from the creative centers of the oceans, where the world is being stitched together, toward the places where the Great Plates finally meet. These are the boundaries of collision, the edges of the map where the silent drift of the continents leads to a slow-motion encounter of unimaginable power. Here, the story of the Earth shifts from the birth of new land to the recycling of the old. Imagine two massive, ancient giants, each the size of a continent, drifting toward one another across a quiet, invisible sea. In the world of geology, we call these meeting points convergent boundaries. They are the slow-motion encounters of our planet, vast, heavy movements that happen at a pace so gradual it is almost impossible for our human senses to perceive. While the ridges we spoke of earlier are places of birth and expansion, these boundaries are places of meeting and transformation. As we begin to explore these immense forces, take a moment to notice the absolute stillness of your own room. Feel the weight of your body against the soft surface of your bed, perfectly supported and safe. Let your shoulders drop away from your ears and feel the gentle rhythm of your own breathing. While the earth beneath us performs these great, heavy movements over millions of years, you are here, In this small pocket of time, surrounded by quiet and peace, when two tectonic plates meet head-on, they rarely just stop. Instead, a fascinating hierarchy of density determines what happens next. Often one plate, usually the thinner, heavier oceanic plate, bows its head to the other. It begins a slow downward journey, sliding beneath the lighter, thicker continental plate. Geologists call this process subduction. It is a graceful, if heavy, descent into the warmth of the Earth's interior. Think of it as a great recycling program on a planetary scale. If the mid-ocean ridges are the nurseries where new crust is born, then subduction zones are the places where the Earth gently reclaims its old surface. As the edge of the sinking plate descends, it leaves the cold, dark floor of the ocean behind and enters the intense heat of the mantle. Here, the rock that was once the solid floor of a sea begins to soften. It warms and eventually melts, merging back into the slow, glowing currents of the inner Earth. Nothing is ever truly lost. The material that once held the weight of the ocean is simply repurposed, destined to rise again in some distant future. This process is what keeps our planet from growing larger, even as new land is created. It is a perfect, closed loop of constant renewal. At the exact point where the sinking plate begins its long dive, the Earth's surface is pulled downward, creating a deep, narrow fold in the crust. These are the oceanic trenches, the deepest, most mysterious scars on the face of our world. They are places of incredible pressure and absolute shadow, where the ocean floor bends away from the sunlight and descends into the quiet of the abyss. As we follow the path of the sinking plate, we find ourselves moving away from the familiar world of waves and light, drifting down into the deepest creases of the Earth's skin. It is here, in these silent, sunken valleys, that the true scale of our planet's power is revealed. Imagine descending through the water, leaving the sun-dappled surface far behind. As the light fades from turquoise to navy, and then to a deep velvety indigo, the world becomes perfectly still. Eventually, the last rays of the sun disappear entirely, and you enter the midnight zone. Here, in the western Pacific Ocean, lies the Mariana Trench, the deepest, quietest place on the entire planet. It is a crescent-shaped scar in the Earth's crust, a silent cathedral of water and stone. At its lowest point, known as the Challenger Deep, the ocean floor sits nearly 11 kilometers below the surface. To visualize this vast distance, imagine taking Mount Everest, the highest peak on Earth, and placing it into the trench. Even then, the summit of the mountain would still be covered by more than 2 kilometers of cold, dark water. It is a depth so profound that it is difficult for the human mind to fully grasp, a place where the weight of the world is felt in every cubic inch of space. The pressure at the bottom of the Mariana Trench is immense, over 1,000 times the pressure we feel at sea level. It is equivalent to the weight of nearly 50 jumbo jets pressing down on a single person. And yet, in this extreme environment, there is a sense of absolute, unshakable peace. There are no storms here, no crashing waves, and no wind. There is only the slow, rhythmic pulse of the planet and the occasional ghostly glimmer of bioluminescent life drifting through the dark like falling stars. This incredible abyss was formed by the very process of subduction we have been discussing. The massive Pacific Plate, which carries much of the floor of the Pacific Ocean, is old, cold, and incredibly dense. As it moves westward, it encounters the smaller Philippine Plate. Because the Pacific Plate is heavier, it begins to dive, curving downward into the mantle in a slow-motion descent that has lasted for millions of years. This downward curve is what creates the trench, a physical manifestation of the Earth folding in on itself. As you lie there, nestled in the comfort of your blankets, try to imagine that profound silence. It is the silence of the Earth's deepest fold, a place where time seems to stretch and slow down. The water is near freezing, the darkness is absolute, and the geological forces at work are moving with a patience that transcends human experience. It is a reminder of how much of our world remains hidden and untouched, resting in a state of eternal quiet dignity. But as the Pacific Plate sinks deeper into the Earth, disappearing into the warmth of the mantle, it does not go quietly. The journey of the sinking rock creates a chain of events that ripple back up toward the surface. While the trench marks the point of descent, the energy and heat generated by this movement begin to shape the world above it in a very different way. The sinking plate carries with it water and minerals that, when subjected to the intense heat of the interior, trigger a remarkable transformation. This transformation will eventually rise back through the crust, breaking the surface of the sea to create new land where once there was only open water. As the massive Pacific Plate continues its slow downward journey into the Earth's mantle, it carries with it more than just cold, ancient rock. It drags down layers of ocean sediment and vast amounts of seawater trapped within the pores of the stone like a sponge. Deep underground, as the pressure and heat intensify, this water is squeezed out and forced into the hot mantle rocks above. This introduction of water acts as a catalyst, lowering the melting point of the rock and creating plumes of buoyant, molten magma. This magma, lighter than the solid rock around it, begins a slow, steady ascent back toward the surface. This is the birth of an island arc, a process of creation that rises directly from the depths of destruction. Imagine, if you can, the quiet darkness of the seafloor being softly interrupted by a glow from beneath the crust. As the magma reaches the surface of the ocean floor, it breaks through in a series of underwater eruptions. In the deep, cold water, the red-orange lava meets the sea with a soft, muffled hiss of steam. The water absorbs the heat instantly, and the molten rock cools into dark, glassy stone, piling layer upon layer, century after century. Eventually, these underwater mountains grow so tall that they break the surface of the waves, feeling the touch of the air and the warmth of the sun for the first time. They emerge as chains of volcanic islands, curved like a bow in the sea, mirroring the shape of the subduction zone far below. These island arcs are some of the most beautiful and rugged landscapes on our planet. The Japanese archipelago, the Aleutian Islands, stretching out from Alaska, and the many islands of the Philippines were all sculpted by this very process. When you look at a map of Japan, you are looking at the tops of a massive underwater mountain range born from the friction and heat of plates colliding in the dark. These islands are not static. They are living, breathing monuments to the Earth's internal energy. Over millions of years, the cooling volcanic stone becomes the foundation for lush forests, fertile soil, and the diverse tapestry of life that eventually calls these new lands home. There is a profound rhythm to this cycle. What was once the cold, dark floor of the deep ocean is recycled, melted, and transformed into mountain peaks that reach for the clouds. It is a reminder that in the grand timeline of our planet, nothing is ever truly lost. It is simply reshaped into something new. As the steam clears and the new stone settles into the rhythm of the tides, we can see that these island arcs are not isolated events. They are part of a much larger, much more powerful pattern that spans the entire globe. This sequence of subduction and creation repeats itself over and over, tracing a vast, glowing path around the edges of the world's largest ocean. This path, defined by the constant movement of the plates and the rising of the Earth's inner fire, forms a great horseshoe-shaped boundary that scientists call the Ring of Fire. This great glowing path, the Ring of Fire, is a 40,000-kilometer horseshoe that traces the edges of the Pacific Ocean. It is perhaps the most active area on our planet, yet when viewed through the lens of deep time, its movements are steady and rhythmic. Think of this activity not as a source of unrest, but as the Earth's way of breathing. Just as you take a slow, deep breath in and out, the Earth is constantly venting its internal heat, releasing pressure and recycling its crust. This process is what keeps our world vibrant and geologically alive, ensuring that our planet does not become a cold, stagnant rock. Within this vast, shimmering circle lie more than 75% of the world's active volcanoes. They stand like silent, snow-capped sentinels around the rim of the Pacific, stretching from the southern tip of South America, up along the rugged coast of the Andes, through the high peaks of Central America, and the Cascades of North America. The line continues across the cold, misty Aleutian Islands, through the volcanic heart of Japan, and down into the lush islands of the Philippines, Indonesia, and New Zealand. It is a nearly continuous chain of subduction zones where the massive Pacific plate is slowly being tucked under the surrounding continental plates. As it descends into the warmth of the mantle, it fuels the fires that build the land above, creating a necklace of peaks that define the boundaries of the world's largest ocean. There is a profound sense of balance in this horseshoe. For every inch of crust that is consumed in the darkness of a trench, new land is being forged in the heat of a volcanic arc. It is a circle of constant creation and change, a reminder that the Earth is never truly finished. It is always refining its shape, always renewing its surface. The heat that moves these plates is the same heat that has sustained the planet for billions of years, a warm, internal glow that ensures the Earth remains a dynamic, changing home. As you lie there, perfectly still, you might imagine the planet itself performing these slow, massive adjustments, settling into its form with the same gentle weight of a person settling into a deep sleep. As we follow this ring, we see how the internal energy of the Earth interacts with the surface in spectacular ways. But the movement of plates doesn't always result in the birth of islands or the venting of magma through volcanic vents. Sometimes the forces involved are even more massive. involving the very hearts of the continents themselves. When two great land masses are pushed together by these same tectonic currents, the crust doesn't just melt or sink, it begins to buckle and fold under the immense pressure. We are moving now from the volcanic fires of the ocean's edge toward the majestic, silent heights of the great continental mountain ranges. Here, the story of the Earth's movement is written not in lava, but in the very bones of the world, the solid rock of the crust that, when pushed with enough slow, patient force, begins to behave like a soft, heavy fabric. These are the fold mountains, nature's way of wrinkling the surface of our world into peaks that touch the sky. Imagine for a moment the ground beneath you, not as a brittle, unyielding stone, but as something with a surprising capacity for grace. When we look at the great mountain ranges of our world, the ones that stretch across continents like giant, sleeping spines, we are often looking at the result of a process called folding. It is nature's way of wrinkling the Earth's crust, a testament to the patient, irresistible power of tectonic movement. To visualize this, imagine a large, heavy rug lying flat on a smooth floor. If you were to place your hands at opposite ends of that rug and very slowly push them toward the center, the fabric wouldn't simply stay flat. It would begin to ripple. It would rise in some places and dip in others, creating a series of soft ridges and valleys. This is precisely what happens to the Earth's crust when two tectonic plates converge over millions of years. The rock, which seems so solid and unbreakable to us, begins to behave like that fabric. Under the immense heat of the Earth's interior and the relentless, slow-motion pressure of the plates, the layers of sedimentary rock begin to bend and arch. Geologists have beautiful rhythmic names for these undulations. When the rock layers arch upward, forming the crest of a mountain ridge, they call it an anticline. You can picture it like the top of a slow stone wave frozen in time, reaching upward toward the sun. Conversely, when the layers dip downward to form a valley, it is called a syncline, a gentle cradle in the earth. These folds can be small enough to see in a single roadside cliff, or they can be so vast that they span entire provinces, creating the rolling topography of the world's most famous highlands. It is a slow, rhythmic process, a dance of stone that takes place over time scales so long they are almost impossible to grasp. The rock doesn't shatter because the pressure is applied with such incredible patience, and because the heat deep within the crust allows the minerals to remain slightly flexible. It is a reminder that even the hardest things can change their shape if given enough time and warmth. Take a moment now to simply breathe. Imagine yourself standing on one of these ancient, folded peaks. The air here is cool and thin, tasting of distant snow and absolute silence. Below you, the world falls away in a series of soft green folds, like a heavy blanket tucked around the shoulders of the earth. Feel the weight of your own blankets, the warmth of your bed, and the absolute stability of the room around you. While the earth may be folding and moving in its own deep time, in this moment, everything is still. You are safe, and the world is at rest. While many mountain ranges exhibit this beautiful folding, there is one place on Earth where this process has reached its most magnificent and towering peak. It is a place where the crust has been pushed so high that it touches the very edge of the atmosphere, a place born from the most monumental collision in our planet's recent history. We are traveling now to the heart of Asia to look upon the greatest fold mountains of all, the roof of the world, the Himalayas. Just the name carries a sense of weight and ancient majesty, a word that translates in Sanskrit to the abode of snow. As we move our focus to this part of the world, imagine the air at these heights. It is incredibly still, so thin and pure that it feels like breathing in the essence of the sky itself. This is the roof of the world, a vast, jagged spine of the earth that stretches for 1,500 miles across the heart of Asia. It is a silent sentinel of stone and ice, a place where the world seems to touch the very edge of the heavens. This range is the ultimate expression of tectonic power, the most dramatic result of the Earth's restless, drifting shell. To understand how these giants were born, we have to look back across a staggering expanse of time. About 50 million years ago, a journey began that would change the map of the world forever. The Indian subcontinent, which was once an island drifting in the southern oceans, was moving steadily northward. It traveled across the ancient Tethys Ocean, sliding slowly but surely toward the massive Eurasian plate. When these two land masses finally met, it wasn't a sudden crash, but a slow-motion encounter of two giants. Because both plates are composed of thick, buoyant continental crust, neither was willing to sink into the dark depths of the mantle. Instead, they did the only thing they could. They crumpled, they folded, they pushed. The rock layers that once sat at the bottom of the ancient sea were squeezed with such immense pressure that they were forced upward, thousands of feet into the air. This was the beginning of a slow, eternal embrace between two continents, a collision that is still happening today. As you lie there, perfectly still and comfortable, imagine that deep, rhythmic pressure. The Indian plate is still pushing northward at a rate of about 5 centimeters every year, roughly the same speed at which your fingernails grow. It is a movement so slow that it is invisible to the eye, yet it is powerful enough to lift entire mountain ranges. The Earth here is locked in a constant, patient struggle. Two continents pressed together in a hug that has lasted for 50 million years. In the vast silence of these high peaks, there is a sense of profound peace. The wind whispers over the ridges, and the snow settles softly on slopes that have never known the footstep of a human. It is a landscape of absolute scale, where time is measured not in hours or days, but in the slow rise of the stone. Feel the stability of the ground beneath you, a stark contrast to the slow upward heave of the Himalayan peaks. You are safe in the stillness of the present, while the mountains continue their long, slow climb. Within this vast sea of peaks, one stands taller than all the others. It is a giant among giants, a pyramid of rock and ice that holds the title of the highest point on our planet. It is a place where the Earth reaches its final limit before meeting the dark velvet of space. Let us turn our mind now to that singular summit, a peak that is not yet finished with its journey toward the stars. Mount Everest, a name that carries the weight of the sky, a peak so high that it touches the very edge of our atmosphere. In the languages of the people who live in its shadow, it is known as Sagarmatha, the goddess of the sky, or Chomolungma, the mother of the world. As you lie there, your breath steady and slow, imagine this colossal pyramid of rock and ice, standing in the profound silence of the high Himalayas. It is the ultimate expression of the Earth's inner power, a monument to the slow-motion collision we have been exploring. But Everest is not a finished work. It is not a static, unmoving object. Even now, in the quiet of this moment, the mountain is reaching for the stars. Because the Indian Plate continues its relentless journey northward, pushing into the heart of Asia, the ground beneath Everest is still being squeezed and lifted. Science tells us that the mountain grows about 4 millimeters higher every single year. It is a growth so subtle that no human eye could ever perceive it. Yet it is as steady as the turning of the seasons. 4 millimeters, about the thickness of 2 small coins stacked together. It is a slow, rhythmic pulse of growth, a reminder that the earth is never truly still, even when it appears most solid. As we visualize the summit, where the wind whispers through the thin, cold air, we find a secret hidden within the stone itself. If you were to stand at the very top of the world and look closely at the rocks beneath your feet, you would find something remarkable. You would see the remains of ancient life. High above the clouds, in a place where no trees grow and the air is too thin for most creatures to survive, the rock is composed of limestone. And within that limestone are the fossilized remains of tiny sea creatures, crinoids, shells, and microscopic organisms that once drifted in a warm, shallow ocean. Take a slow, deep breath and let that thought settle. The highest point on our planet was once the bottom of a vast sea. The stone that now feels the first light of the morning sun once sat in the dark, quiet depths of the Tethys Ocean, millions of years ago. This is the great payoff of the Earth's long memory. The top of the world was once the seabed. The tiny shells of creatures that lived and died in the water have been lifted nearly 9 kilometers into the air, carried upward by the incredible strength of the tectonic plates. It is a transformation that defies our everyday sense of time, a journey from the deep blue of the ocean to the white peaks of the heavens. The silence of Everest is a heavy, peaceful silence, a place where the history of the world is written in layers of ancient limestone and ice. It reminds us that everything on our planet is in a state of constant, gentle flux. What is high was once low. What is divided was once joined. But as we leave these snowy, towering heights of Asia, let us allow our minds to travel. We drift away from the vertical majesty of the Himalayas and move across the vast, blue expanse of the Pacific Ocean. We are heading toward another continent, toward a different kind of giant. Here, the mountains do not just reach for the sky, they stretch across the horizon in a line that seems to have no end. We are traveling to the spine of South America to witness the longest continental mountain range on Earth. Within its peaks, we will find not just the evidence of folding stone, but the warm, glowing power of the Earth's internal fire. As we drift away from the thin air of the Himalayas, our journey takes us across the vast moonlit expanse of the Pacific. We are moving toward the western edge of South America, where a different kind of giant waits in the stillness. Here, stretching like a long ancient spine along the coast, are the Andes. This is the longest continental mountain range on Earth, a continuous wall of stone and ice that spans over 7,000 kilometers. It reaches from the tropical warmth of the north all the way to the frozen, wind-swept islands of the south, tracing the edge of the continent like a rugged, protective border. Visualize this massive range from high above. It is not just a single line of peaks, but a complex tapestry of high windswept plateaus and sharp, jagged summits that pierce the clouds. Take a slow, quiet breath and imagine the contrast of this landscape. In the center of the range lies the Altiplano, a vast, high-altitude plateau where the air is still and the horizon seems to stretch forever. It is a place of silent salt flats and deep blue lakes, held high in the sky by the incredible forces of the earth. But surrounding these quiet flats are the peaks themselves, sharp, dramatic, and often capped with eternal snow. The story of the Andes is one of a slow-motion encounter between two massive pieces of the Earth's crust. To the west, beneath the Pacific Ocean, lies the Nazca Plate. It is a heavy, dense slab of oceanic crust, and for millions of years it has been moving steadily eastward. When it meets the lighter, thicker South American plate, a process called subduction occurs. The Nazca Plate does not simply crash. It bows its head and slides deep beneath the continent, sinking back into the warm, semi-solid mantle. It is a graceful, if powerful, descent, a recycling of the ocean floor into the deep interior of the planet. As the oceanic plate descends, it carries with it water and minerals from the sea floor. Deep underground, the intense pressure and heat cause these materials to melt, creating pockets of molten rock or magma. This magma is lighter than the surrounding stone, and so it begins a slow, patient journey upward. This is why the Andes are unique. They are a mountain range built by both folding and fire. While the pressure of the plates causes the crust to wrinkle and fold into high ridges, the rising magma fuels some of the most spectacular volcanoes on our planet. In fact, the Andes are home to the highest volcanoes in the world. Peaks like Ojos del Salado stand as silent sentinels over 6,000 meters high, their internal fires currently resting beneath coats of ice. It is a landscape of incredible power, held in a delicate balance, the cold, solid stone of the mountains being constantly shaped and reshaped by the warmth rising from deep within the earth. As you settle deeper into your blankets, imagine that warmth. Think of the earth not as a cold, dead rock, but as a living vessel of energy. The mountains are not just static monuments. They are the surface expression of a great internal heat. This fire is what drives the movement of the plates, what melts the stone, and what builds the peaks that reach for the stars. We are beginning to see how the Earth's inner life creates the outer world we know. To understand this better, we must look more closely at the mountains born entirely from this internal glow, the mountains made of fire and ash. While some mountains are formed by the slow, immense pressure of two continents meeting, others are born more directly from the Earth's internal heat. These are the volcanic mountains, peaks that rise not from the wrinkling of the crust, but from a steady, rhythmic outpouring of the planet's inner life. They are the visible breath of a world that is still very much alive and warm beneath our feet. Imagine, if you will, a quiet night on the slopes of such a mountain. The air is cool and still, and the stars above are bright and unblinking. Far beneath the soil and the roots of the trees, the earth is moving. Pockets of magma driven by the intense heat of the mantle and the gases trapped within the stone, are rising slowly through the crust. When this molten rock reaches the surface, it does not always arrive with violence. Often, it is a slow, patient process. The lava flows out, glowing with a soft, warm light against the dark earth, before it eventually cools and hardens into new land. These peaks are often called composite volcanoes or stratovolcanoes because they are built layer by layer. It is a process that requires vast stretches of time and a peculiar kind of geological patience. One year, a layer of fine gray ash might settle over the slopes like a heavy blanket of snow. Centuries later, a flow of thick, viscous lava might crawl over that ash, sealing it away and adding a new, solid shell to the mountain's frame. This alternating rhythm of ash and lava, of soft and hard, is what gives these mountains their strength and their iconic sloping shapes. Mount Fuji, standing solitary and proud in Japan, is perhaps the most perfect example of this natural architecture. Its symmetry is so precise it feels almost intentional, yet it is simply the result of gravity and the even flow of volcanic material over many millennia. Similarly, Mount Rainier in the United States towers over the landscape, a massive monument of stone and ice that has been built up by countless eruptions over the last 500,000 years. When you look at these peaks, you are looking at a history of the Earth's internal temperature recorded in stone. There is a unique peace to be found in these mountains. Though they are born from heat and pressure, they spend most of their lives in deep silence, draped in glaciers and alpine forests. They are temporary monuments to the Earth's energy. On the grand scale of geological time, a volcanic peak may rise, stand for 1,000,000 years, and then be worn away by the wind or transformed by a new shift in the plates. They act as a brief but beautiful bridge between the molten world below and the cool air of the atmosphere. It is a reminder that the ground we walk upon is always in a state of becoming, fueled by a fire that never truly goes out. Yet, the Earth has other ways of shaping the horizon. While some parts of the crust fold like fabric and others rise as volcanic cones, there are places where the stone is too rigid to bend and too cool to flow. In these regions, the immense stresses of the shifting plates cause the Earth to do something quite different. Instead of folding or erupting, the very foundation of the land begins to crack and tear. This creates a landscape of sharp, dramatic geometry, a world of massive blocks and deep valleys that tells a story of a planet being pulled apart. When we think of mountains, we often imagine the soft, rolling curves of ancient hills or the jagged, snow-dusted peaks formed by massive collisions. But there is another kind of majesty found in the landscape, one defined by straight lines, sharp edges, and a sense of geometric order. These are the block mountains, born from the dramatic tearing and fracturing of the Earth's rigid outer shell. Imagine for a moment that the Earth's crust is like a thick slab of cold, dark chocolate. If you pull at it slowly, it might stretch just a little, but eventually it will snap. It breaks into distinct solid pieces. This is what happens in regions where the tectonic plates are being pulled in opposite directions. The crust is stretched until it can no longer hold its integrity. It faults or cracks, creating massive fissures that reach deep into the stone. When these cracks form, the huge blocks of rock between them begin to move. Some are pushed upward by the pressure from below, while others slide downward, settling into the gaps left behind. The result is a landscape of high, flat-topped ridges and deep, wide valleys. It is a process of tilting and shifting like a set of heavy books leaning against one another on a shelf. The Sierra Nevada mountains in the western United States are perhaps the most famous example of this tectonic architecture. If you were to look at them from above, you would see a massive block of the Earth's crust, roughly 400 miles long, that has been tilted like a giant trapdoor. One side, the eastern face, is a sheer, dramatic wall of granite that rises abruptly from the desert floor. The other side slopes gently toward the west, disappearing into the fertile soil of the California valleys. It is a mountain range built not by folding or by fire, but by the sheer patient force of breaking. Geologists have specific, almost rhythmic names for these features. The raised blocks, the ones that stand tall as mountains, are called horsts. The word comes from an old term for a thicket or a high place. These are the pillars of the landscape, the remnants of the crust that refuse to sink. Between these horsts lie the grabens. In German, the word means ditch or trench. These are the valleys that have dropped down, cradled between the rising peaks. Together, they create a basin and range topography, a rhythmic pattern of ups and downs that can stretch for hundreds of miles across the horizon. Take a slow, deep breath and imagine this immense landscape. Picture yourself standing on the edge of a great horst, looking out over the vast, silent graben below. The air is cool and still, and the shadows of the clouds drift slowly across the flat valley floor. There is a profound sense of stability here, despite the fact that the ground beneath you was once part of a massive, tearing event. The earth has a way of settling into its new shapes, finding a quiet equilibrium after the stress has passed. This process of tearing isn't just a part of the ancient past. Even now, in certain corners of our world, the crust is actively being pulled apart, creating new valleys and preparing the way for oceans that do not yet exist. One such place is a vast stretch of land where the earth is literally opening up, revealing a glimpse into the future of our continents and the birth of a new sea. The place I'm speaking of is the East African Rift. It is a landscape of immense beauty and profound historical significance, often called the cradle of humanity. This is the land where our earliest ancestors walked millions of years ago under a vast, sun-drenched sky that stretches over golden plains. But beneath this peaceful surface, the earth is engaged in a slow, dramatic transformation. The African continent, which seems so solid and permanent, is actually being pulled apart from within. This is a divergent boundary, a place where the Earth's internal heat is pushing upward and outward, stretching the crust until it thins and begins to snap. Specifically, the massive African plate is splitting into two smaller pieces, the Somalian plate to the east and the Nubian plate to the west. It is a slow-motion divorce of a continent happening at a pace of just a few millimeters each year, about the same speed that your fingernails grow. It is a quiet, persistent widening that is reshaping the face of the world. As the ground pulls apart, the center drops down, creating a massive valley system that stretches for thousands of miles. This isn't just a single crack in the earth, it is a complex network of rifts and faults. Where the ground is dropped deep enough, water has rushed in to fill the gaps, creating some of the deepest and oldest lakes on our planet. Consider Lake Tanganyika. It is a long, narrow ribbon of blue held within the steep, high walls of the rift. Its waters are incredibly deep and still, reaching down nearly a mile into the Earth's crust. It is a beautiful, silent reminder that when the Earth opens, it creates space for something new, for water, for unique ecosystems, and eventually for a new sea. In the very distant future, perhaps 10 or 50 million years from now, this rift will widen so much that the Indian Ocean will come flooding in. The Horn of Africa will become a massive island, separated from the main continent by a brand new ocean. It is a humbling thought to realize that the maps we study today are merely a single frame in a very long, very slow movie of planetary change. Take a slow, deep breath and imagine the vastness of this process. Picture the slow widening of a valley over 1 million years. There is no rush in this movement. The Earth is patient, working on a scale of time that far exceeds our own. Feel the stability of your own bed, and then imagine the deep rhythmic peace of a continent slowly finding a new shape. The ground is moving, but it moves with such grace and steadiness that the life above it continues to flourish undisturbed. While the East African Rift shows us the birth of new features and the tearing of the young crust, other parts of our world tell a much older story. Not all mountains are sharp and jagged, and not all valleys are newly formed. In some places, the Earth's great movements happened so long ago that the land has had time to settle and soften. The sharp peaks have been rounded by time, and the deep scars have been covered by ancient forests. We move now from the sun-drenched active rifts of Africa to the gentle, misty ridges of a mountain range that serves as an elder to the world. Consider the Appalachian Mountains, stretching with a quiet dignity along the eastern edge of North America. They do not demand your attention with soaring, jagged summits or dramatic, snow-covered cliffs that pierce the clouds. Instead, they offer a different kind of beauty, a steady, enduring presence that feels deeply settled. These are the gentle, ancient elders of the mountain world. When you look at them from a distance or walk along their winding, shaded trails, you see soft, rounded green ridges that seem to roll like the waves of a slow emerald sea. There is a profound peace in this landscape, found in the deep silence of the valleys and the scent of damp earth and ancient pine needles that hangs in the cool, misty morning air. To understand the Appalachians, we must look back much further into the past than the birth of the Himalayas or the Alps. These mountains began to rise nearly 480 million years ago, during a time when the Earth's land masses looked nothing like they do today. Long before the first dinosaurs appeared, the ancestors of these mountains were born from a series of massive continental collisions that eventually helped stitch together the supercontinent of Pangaea. In those distant days, the Appalachians were not the soft hills we see now. The collision of tectonic plates was so immense and so powerful that it pushed the crust upward into a range that was once as tall, sharp, and formidable as the Himalayas are today. Imagine these same ridges, but reaching miles into the sky, capped with ice and surrounded by a world that was still finding its shape. It is a staggering thought to realize that the soft, rolling peaks we see today were once giants. But time is the great leveler of the natural world. Over hundreds of millions of years, the Earth has been incredibly patient. While tectonic forces were busy building new mountains elsewhere, the Appalachians were subjected to the slow, relentless work of the sky. The wind has whispered against the stone for eons, and the rain has washed over the slopes, carrying away the mountain grain by grain, pebble by pebble. Even the greatest giants are eventually smoothed and humbled by the patient touch of the atmosphere. The Appalachians stand today not as a monument to sudden geological violence, but as a testament to the quiet power of endurance. They remind us that there is a season for everything, a time for rising in jagged glory, and a time for resting in soft, green maturity. They have watched the world change for nearly 500 million years, standing guard as life moved from the oceans onto the land, and as forests grew to cover their weathered flanks. As these ancient peaks settled into their current peaceful state, they left behind a map of the forces that continue to shape our world. The story of the Appalachians is not just a story of growth, but a story of how the Earth slowly, carefully dismantles what it has built. It leads us to wonder about the invisible hands that work upon the landscape every single day, often so slowly that we cannot see them moving. To understand how a mountain eventually returns to the sea, we must look closer at the patient sculptors of the earth, the forces of erosion that reshape the world while we sleep. If the tectonic plates are the master builders of our world, then erosion is its patient, tireless sculptor. While the internal heat of the earth works deep below to push the crust upward, creating jagged peaks that pierce the clouds, the atmosphere works just as diligently from above to pull them back down. It is a slow, rhythmic dance between the forces of creation and the forces of refinement. Take a moment to imagine the sound of a tiny, clear stream trickling over a bed of smooth stones. It is a delicate sound, almost fragile. Or listen to the soft, rhythmic whisper of the wind as it brushes against a high canyon wall. In a single moment, these forces seem insignificant. But when they are multiplied by millions of years, they possess a quiet power that can dismantle the highest mountain ranges on the planet. This is the process of erosion, the Earth's way of recycling its landscape, grain by grain. Water is perhaps the most effective of these sculptors. It begins as a single raindrop falling softly onto a mountain ridge. That raindrop finds a microscopic crack in the rock. In the cold of the night, it freezes and expands, acting like a tiny wedge that pushes the stone apart. When the sun rises and the ice melts, it carries a speck of dust away with it. Over eons, these specks become pebbles, and the pebbles become boulders. Every river you see is a conveyor belt, silently carrying the mountains toward the sea. The mud at the bottom of a delta and the sand on a distant beach are simply the remains of ancient peaks that have finally completed their long journey home. There is a constant tug-of-war happening on the surface of our planet, a state of balance between tectonic uplift and erosional knockdown. When a mountain range is young, the uplift is winning, The plates are pushing the rock up faster than the rain can wash it away. But as the millions of years pass, the sculptor takes the lead, smoothing the sharp edges and rounding the summits until the giants become the rolling green hills we find so peaceful. The wind, too, plays its part. In the high deserts and open plains, it carries abrasive grains of sand, using them like sandpaper to polish and shape the stone into arches and towers. It is a slow, invisible art form. But as powerful as the wind and water are, there is another agent of change, one that is heavier, colder, and more transformative than any other. It is a force that doesn't just wash the land away, but grinds it down with immense, crushing weight. To see the most dramatic work of the earth sculptors, we must look to the slow blue rivers of ice that have carved the world's most iconic landscapes, moving with a patience that only the earth can truly understand. These are the glaciers, the blue rivers of ice that serve as the earth's most powerful and patient sculptors. While a river of water is quick and nimble, a glacier is a massive, heavy blanket of frozen snow that has been compressed over centuries into a dense, crystalline blue. It does not flow like water. Instead, it moves with a deep, low-frequency groan, shifting under its own immense weight. To stand near one is to feel a sense of profound stillness. Yet, beneath that frozen surface, a monumental amount of work is being done. As you settle deeper into your pillows, imagine the weight of this ice, sometimes kilometers thick, pressing down upon the solid bedrock. It moves through a process called internal deformation, where the ice becomes plastic and begins to slide and flow like cold honey. This movement is incredibly slow, often only a few centimeters or meters a day, but its power is unmatched. A glacier does not flow around obstacles, it grinds through them. While a river of water cuts a sharp, narrow V shape into a mountainside, a glacier acts like a giant, heavy scoop. It widens the floor and steepens the walls, leaving behind what geologists call a U-shaped valley. These are the vast, majestic valleys with flat bottoms and vertical cliffs that we see in places like Yosemite or the Scottish Highlands. At the base of the ice, rocks and pebbles are trapped and frozen into the glacier's belly. These tions act like the grit on a piece of cosmic sandpaper, polishing the bedrock beneath and leaving behind long, straight scratches known as striations. These marks are the physical records of the ice's journey, pointing the way the glacier once traveled thousands of years ago. The glacier is also a master of transport. It can pick up boulders the size of houses, massive stones weighing hundreds of tons, and carry them hundreds of miles away from their original home. When the ice finally melts and retreats, it leaves these boulders stranded in open fields or atop different types of rock where they don't seem to belong. These are known as erratics, silent, ancient travelers that mark the path of the ice's reach. Even the color of the mountains is affected by this process. The constant grinding of stone against stone creates a fine, powdery silt called glacial flour. When this silt finds its way into mountain lakes, it stays suspended in the water, reflecting the light to create an ethereal, milky turquoise glow that looks almost magical under a summer sun. The jagged, iconic beauty of the European Alps and the deep water-filled fjords of Norway are the enduring handiwork of these rivers of ice. The fjords, in particular, are simply glacial valleys that were carved so deeply that the sea rushed in to fill them once the ice vanished. It is a reminder that even the hardest granite can be reshaped by the softest snowflake, provided it has the gift of time and the weight of 1,000 winters. But as we leave these ice-carved peaks behind, we must remember that the Earth is not only shaped by the friction of colliding plates or the grinding of glaciers. Sometimes mountains and islands are born in the most unexpected of places, not at the turbulent edges of the tectonic plates, but right in the very center of them. These are the lonely giants, born from deep, stationary plumes of heat that reach up from the Earth's interior to pierce the crust, creating a trail of wonders across the surface of our moving world. Imagine, if you will, a single steady fountain of heat rising from the very depths of the Earth's mantle. Unlike the chaotic boundaries where plates clash and buckle, these features, known as hot spots, are remarkably still. They act like stationary beacons of energy, rooted deep within the planet, while the massive tectonic plates drift solely and silently above them. It is a rhythmic, almost poetic process. A plume of molten rock pierces through the crust to create a volcano, only for that volcano to be carried away by the moving plate, leaving room for a new one to be born in its wake. Take a deep, slow breath and visualize the vastness of the Pacific Ocean. Beneath its rolling blue surface lies the most famous example of this phenomenon, the Hawaiian Islands. Each island in the chain is a monument to a specific moment in time. The Big Island of Hawaii, with its glowing lavas and towering peaks, is the youngest, currently sitting directly over the hotspot. But as you move northwest, the islands become older, smaller, and more weathered. Maui, Oahu, and Kauai were once where the Big Island is now, but the Pacific Plate has carried them away, centimeter by centimeter, over millions of years. This trail doesn't end with the islands we see above the waves. If you were to drain the ocean, you would see a magnificent submerged mountain range stretching for thousands of miles. This is the Hawaiian Emperor Seamount Chain. It is a geological breadcrumb trail that tells a story 80 million years long. These ancient underwater peaks were once lush volcanic islands, but as they moved further from the heat of the hotspot, they cooled, contracted, and were slowly reclaimed by the sea. About 3,500 miles away from Hawaii, the oldest of these seamounts are finally being swallowed by the Aleutian Trench, a quiet end to a journey that began when dinosaurs still walked the earth. There is a fascinating bend in this long chain of mountains, a sharp turn that occurred about 47 million years ago. It serves as a silent record of a time when the Pacific Plate itself changed its direction of travel. It is as if the Earth left us a map of its ancient movements, written in stone on the seafloor. And even now, the process continues. To the southeast of the Big Island, deep beneath the waves, a new mountain called Kame'ehuakanalo, formerly known as Lo'ihi, is already forming. It hasn't yet broken the surface, but in perhaps 100,000 years, it will become the next Hawaiian island, rising into the sunlight as the plate continues its endless, patient drift. These hotspots remind us that the Earth's interior is a place of focused, enduring power. They create life and land in the middle of the deepest isolation. But while some plates move over these plumes or crash into one another, to build mountains, there is another type of movement, one that is perhaps the most tense and mysterious of all. Sometimes, plates do not meet head-on or pull away. Instead, they simply slide past one another, side by side, in a slow, grinding dance that holds its breath for years at a time. Imagine two massive stone giants standing shoulder to shoulder in the dim light of geological time. They are not pulling apart to create a void, nor are they crashing together to build a mountain. Instead, they are simply trying to walk past one another. This is the essence of a transform boundary, a horizontal dance where the Earth's tectonic plates grind side by side in a slow, patient struggle of friction and release. Unlike the other boundaries we have explored, where the Earth's crust is either born in fire or recycled in the deep trenches, transform boundaries are places of conservation. Here, the crust is neither created nor destroyed. It is simply relocated. It is a world of pure movement, where the landscape is shifted, bit by bit, over millions of years. The most famous of these boundaries is the San Andreas Fault, a visible scar that runs for 800 miles through the golden hills and valleys of California. It marks the meeting point of the Pacific Plate and the North American Plate. If you were to look down from high above, you might see the subtle offsets in the landscape, a stream that suddenly turns at a right angle or a row of trees that no longer aligns. These are the footprints of the plates as they slide past each other. The Pacific Plate is moving slowly to the northwest, carrying the coastal sliver of California with it, while the rest of the continent remains anchored. It is a journey so gradual that Los Angeles is creeping towards San Francisco at about the same speed your fingernails grow. In several million years, these two cities, now hundreds of miles apart, will become neighbors. But this movement is rarely a smooth glide, because the edges of the plates are made of cold, jagged rock. They do not slide easily. They catch on one another. They snag and lock, holding their breath for years, decades, or even centuries. During these long periods of stillness, the energy from the Earth's internal heat continues to push them, building up a silent tension deep within the stone. It is a profound, heavy pressure, like a spring being slowly compressed. Eventually, the friction can no longer hold the weight of the plates. The rock gives way in a sudden, sharp release of energy, and the plates leap forward to catch up with where they were meant to be. This is the Earth's way of adjusting its posture, a momentary shudder that restores the balance of forces before returning to a long, deep silence. As you listen to the story of these shifting giants, take a moment to feel the absolute stability of your own surroundings. Feel the weight of your body pressing into the mattress, the stillness of the air in the room, and the quiet safety of the four walls around you, while the earth performs these slow, monumental adjustments miles beneath your feet. You are held in a cradle of peace. The ground beneath you is solid and supportive, a silent guardian that has remained unchanged throughout your entire life. You can let go of the day knowing that the planet is simply breathing, shifting its weight with the patient rhythm of the ages. This horizontal grinding is just one part of a much larger, more majestic pattern. The pulling apart, the crashing together, and the sliding past are all individual steps in a grand choreography that spans billions of years. Geologists call this the Wilson cycle, the ultimate rhythm of our planet. It is the story of how oceans are born, how they grow into vast blue expanses, and how they eventually fade away to bring the continents back together in a warm stone embrace. It is a cycle of constant recycling, a reminder that on our living earth, nothing is ever truly lost, only transformed. Imagine the Wilson cycle as the long, slow heartbeat of the earth. It is a process so vast and patient that it takes hundreds of millions of years to complete a single pulse. This cycle is the biography of an ocean basin, tracing its life from the very first crack in a continent to the final moment when that ocean vanishes and the land becomes whole again. It is the ultimate rhythm of our planet, a grand loop of creation and return that has repeated itself many times over the billions of years of Earth's history. The cycle begins with a quiet stretching. Deep beneath a solid continent, the mantle begins to well up, its warmth softening the crust above. The land begins to thin and pull apart, creating a rift valley, a long, deep scar on the surface. We see this today in East Africa, where the earth is slowly opening its arms. As the rift deepens and drops below sea level, the surrounding waters begin to trickle in. What was once a valley becomes a narrow, salty sea, much like the Red Sea is today. This is the birth of an ocean, a new blue vein appearing on the face of the world. As you breathe in slowly and feel the calm of the night, visualize that narrow sea beginning to widen. For millions of years, the seafloor spreads, pushing the continents further and further apart. The ocean matures, becoming a vast, deep expanse that separates entire civilizations. This is the stage the Atlantic Ocean is in right now, a wide, stable basin that continues to grow by a few centimeters every year. It feels as though it has always been there and always will be. But in the eyes of deep time, this is simply the midpoint of the journey. Eventually, the cycle reaches a turning point. The older, colder edges of the ocean floor become heavy and dense. They begin to bow downward, sliding back into the warmth of the mantle in a process of subduction. The ocean, once growing, begins to shrink. The continents on either side, which had spent eons drifting apart, are now being pulled back toward one another. The Pacific Ocean is currently in this stage of its life, surrounded by trenches where the seafloor is being recycled, slowly narrowing the distance between the Americas and Asia. The final act of the Wilson cycle is a homecoming. The last remnants of the ocean floor disappear into the earth, and the two continents finally meet. They do not crash with a sound, but with a silent, irresistible pressure that folds the crust into the sky, creating massive mountain ranges like the Himalayas. The ocean is gone, its memory preserved only in the marine fossils left high upon the mountain peaks. The land is unified once more, forming a single, massive block of crust. It is a profound realization to think of the earth as a closed system of constant recycling. The very floor of the sea you might imagine in your dreams today may one day be the stone of a mountain, and that mountain will eventually be ground down into sand to settle back onto a new seafloor. Nothing is ever truly lost. It is only rearranged in a beautiful, eternal loop. This process ensures that our planet remains balanced and renewed, shifting its weight with a grace that spans the ages. As we rest in the quiet of the present moment, we can begin to look forward, peering into the distant future of our geography, to see how these wandering continents will find their way back to each other once again. As we drift toward the horizon of the future, let your mind travel forward across the vast expanse of time, leaving the world as we know it behind. Scientists have a name for the destination we are heading toward: Pangea Proxima, or the next Pangea. It is a vision of our world approximately 250 million years from now, a time when the wandering continents will have completed another lap of their eternal dance and gathered once again into a single massive embrace. Visualize the map of the world you know so well, the familiar shapes of the 7 continents, and watch as they begin to slowly soften and shift, like pieces of ice melting and merging in a quiet pond. In this future world, the geography is unrecognizable, yet strangely harmonious. Africa, continuing its slow journey northward, will eventually collide with Europe. The Mediterranean Sea, which has sat like a blue jewel between them for eons, will be squeezed out of existence, its floor pushed upward to form a magnificent new mountain range. These peaks, perhaps taller and more jagged than the Alps, will stretch across what is now southern Europe and northern Africa, a silent monument to the power of tectonic movement. To the east, Australia is on a steady course toward the north. It will likely cross the equator, sliding past the islands of Indonesia to eventually dock against the side of Asia. In this slow-motion world, the vast distances of the Southern Ocean are gradually erased. Meanwhile, the Atlantic Ocean, which is currently widening with every passing year, may eventually reach its limit. In the deep future, new subduction zones could form along the coasts of the Americas, pulling the Atlantic seafloor back down into the mantle. The great ocean that separates the old world from the new will begin to shrink, drawing the Americas back toward Africa and Europe until they touch once more. It is a peaceful thought to realize that the map we study in school is not a permanent fixture. It is merely a single frame in a very long movie, a movie that has been playing for 4.5 billion years and will continue long after we have finished our rest. The borders we draw and the coastlines we map are temporary sketches on the surface of a living, breathing planet. When we look at the world this way, the divisions between us seem to fade. We are all passengers on these great plates, moving together through the silence of space. As you settle deeper into the warmth of your bed, imagine the earth as a patient artist, never satisfied with a single design, always rearranging the land to create something new. This cycle of assembly and disassembly is the heartbeat of our world. It ensures that the earth remains geologically young, constantly renewing its surface and recycling its treasures. The mountains we see today are the ghosts of ancient oceans, and the oceans of the future are currently hidden beneath the weight of the land. Everything is in motion, yet everything is still. The ground beneath you is drifting at the same speed your fingernails grow, a pace so gentle and so steady that it serves as a lullaby for the entire planet. We are part of a grand, slow-moving story that spans hundreds of millions of years, a story that reminds us of the quiet power of persistence. As we prepare to leave the future and return to the stillness of the present, take comfort in the knowledge that the earth is taking care of itself, shifting its weight and finding its balance, just as you are finding yours in the quiet of the night. And so, as we return from the distant horizons of the future and settle back into the quiet of the present moment, we find ourselves once again in the gentle embrace of the here and now. The journey we have taken tonight has been a long one, spanning billions of years and reaching into every hidden corner of our planet. From the white-hot core spinning deep beneath our feet to the highest snow-dusted peaks of the Himalayas, we have witnessed the silent, tireless machinery of the Earth. Throughout this exploration, we have touched upon 150 different facts and stories about the world we call home. We have learned how the Earth is not a static, finished object, but a living system of layers and cycles. We have seen how the crust is divided into massive plates that glide upon a sea of warm, ductile rock, moving with a patience that exceeds human comprehension. We have watched as oceans opened and closed like the slow breathing of a giant, and how mountains were raised by the collision of continents, only to be softened and shaped by the gentle touch of wind and ice. Even now, as you lie in the stillness of your room, this great work continues. The ground beneath your bed is not truly still. It is drifting, carrying you along on a journey that never truly ends. The plates are shifting by a few millimeters. The mid-Atlantic ridge is cooling new seafloor, and the roots of the Andes are being pressed deeper into the mantle. The Earth does not need to hurry. It operates on the scale of deep time, a rhythm that is far more rhythmic and steady than the ticking of a clock. There is a profound peace in this realization. You are not separate from these processes. You are a part of them. The same elements that make up the ancient stardust in the Earth's core are the same elements that allow you to breathe, to dream, and to rest. The planet is holding you, supporting you with its immense gravity, and keeping you safe within its atmosphere as it journeys through the stars. The mountains we spoke of are standing guard in the distance, their heavy stone foundations anchored deep in the crust, enduring through the ages. Take one more slow, deep breath, feeling the air fill your lungs, and then leave you just as easily. Let the weight of your body sink into the mattress, mirroring the way the continents settle into the mantle. There is nothing left for you to do tonight, and no more facts to learn. The story of the Earth is written in the rocks and the tides, and it will continue to unfold while you sleep, constant and reliable. The world is wide, the history of time is vast, and you are right where you need to be. As the light of the day remains a distant memory, and the shadows of the night wrap around you like a soft velvet cloak, let yourself drift off into a deep, dreamless slumber. The eternal drift of the continents will continue its slow, beautiful dance, and the Earth will keep turning, cradling you in its ancient, quiet power. Sleep now, and find your rest in the silence of deep time. Good night.